Okay guys, video 3 for our lesson here. So example 4 says, if we suppose that xy, let me zoom in a little bit so you can see that better. If we suppose that xy is parallel to x prime y prime. So to put that in perspective, we have x, excuse me, let me try that again. We have x and y, and then we have x prime and y prime. If we suppose that xy is parallel to xy prime, we can use the information provided to determine if OXY is similar to OX prime and OY prime, or just Y prime. So here's OX prime and OY prime. So these angles. Since we assume xy is congruent to x prime, y prime, they're parallel to, sorry, that is the symbol for parallel. Let me try that again. So that symbol means parallel, in math anyway. It looks like a little pause symbol almost. When we know we have similar triangles because each triangle shares, then we know that we have similar triangles because each triangle shares an angle with O. And the corresponding angles are congruent. Angle OXY is congruent. That's the congruent symbol. Let me try that again. It's congruent to angle OX prime and OY. And angle OYX is congruent to OY prime, X prime. By the AA criterion, we can conclude that OXY is similar to OX prime, Y prime. Now that we know that the triangles are similar, can we determine the length of side OX prime? By the converse of FTS, which means doing FTS backwards, or in reverse. Since we are given parallel lines and the lengths of the corresponding sides of xy and x prime y prime, we can write the ratio that represents the scale factor and compute using the factor that cross products must be equal to determine the length of OX prime. Write the ratio for the known side lengths xy and x prime y prime, and the ratio that would contain the side lengths we are looking for. Then we use the cross products to find the length of OX prime. So what that looks like is x prime y prime over xy equals OX prime over OX. It's the same as saying, so if we look up here, OX is equal to 4, OY is equal to 6, XY is equal to 5, X prime Y prime is equal to 625. 6.25, I should say. So this is the same. We have X prime Y prime. That is equivalent to 6.25. XY is equivalent to 5. As you can see, it says right here. So always look for your answers up in the information. Make it simple. Don't make it harder than it really is. It looks like a lot of numbers, but it's actually really simple. You just have to look for the right information. OX prime, we don't know. OX prime, we don't know. It's an unknown. That can be our x. XY is 4. OX is 4. OX is 4. So we know OX is 4. All right. So instead of using x, since they used ox, that gets confusing. So down here they use z. So instead we're going to say this is z. Remember that any letter means an unknown quantity or a variable, which means that the number can change or simply is unknown right now. So our variable is going to be represented with the letter z. So we have 6.25 over 5 equals z over 4. And we have the prime symbol here because it is our prime. Or equivalently, 5 times z equals 25. Why 25? Well, 6.25 into 4. And z equals 5. So, therefore, the length of ox prime is 5. Now if we now find the length of oy prime. Well, you would put x prime y prime over xy equals oy prime over oy is the same as saying we know that this is 6.25. We know that this is 5. We know that oy is 6. We know that oy prime is what we don't know. That's our z. Okay? So, let w represent the length of side oy prime. They said w, so we're going to do that instead of z. Because it's a different, we should do that because it's a different value than z. Z is a totally different number. So we always use different letters to represent the different numbers that we don't know in a problem. Let w represent the length of side oy prime. Then we have 6.25 over 5 equals w over 6 prime, or equivalently 5 times w, because we cross multiply, equals 37.5. And because we get 37.5 when we do 6.25 times 6. So w equals 75. Therefore, the length of oy is 75. Okay. I will see you guys in the next example.